Hello, this is Scott Dahman of PowerWorld Corporation. In this section, we will discuss aggregation objects in the power system model, such as areas, zones, interfaces, injection groups, and more. We will show how to create and modify them, and also how to show them on one-line diagrams. We also discuss the use of the difference flows tool.
The things that a lot of our customers are interested in using are interfaces and injection groups, especially because those are used in other tools as well, like the PV analysis, QV analysis, ATC, things like that. It's just a handy way for controlling the transfer of power between different points in the system. Okay, so these are some of the different types that we have. Areas and zones are pretty common across all power system software, like GE PSLF will have areas and zones, and PSSE will also have it. And they also do interfaces too. Some of this other stuff, though, is kind of particular to PowerWorld Simulator. The term for interfaces in industry can be varied. Some areas use the term flow gates, cut planes, and paths. Paths are used out west, I know. And really what you do in PowerWorld Simulator to make a path is you create an interface object. Nomograms are something that we added to the software many years ago, actually to help in the Northwest with some of the analysis. And what that involves is two different interfaces that can have their own individual limits, but then also have a limit in the two-dimensional space involving both interfaces. So in other words, maybe you have a situation where interface A will support a certain flow and interface B will support a certain flow. But if the flow on interface A is really high, then B's got a lower limit and vice versa. So you can create that like two-dimensional limit representation with a nomogram. Super areas are particular, I believe, to PowerWorld Simulator, and what this allows you to do is to combine areas together into effectively a single area. So it's useful for like doing RTO type analysis or ISO analysis. Like, for example, in California, maybe you want to take the PJM area and the San Diego area and the Southern Cal Edison area and combine those into a California ISO super area. And then that allows you to still keep the underlying area structure, but for dispatch purposes, treat it all as one so that the power can flow freely between the member areas without restrictions on that or import-export restrictions. And like I mentioned earlier, injection groups allow you to group together generators and loads to serve as buyers and sellers in ATC or as sources and sinks in PV analysis and things like that. So substations are starting to be supported. I know in the EPC format, it's kind of a recent thing. And that's good to see. I think it's helpful for the industry. It's helpful for our customers because they'll be kind of like a standard for grouping buses together into substations in the West. And they're also starting to put geographic information in, which is really helpful for geomagnetic induced current analysis, which is something that the industry's taken on in the last 5 or 10 years or so. And geographic information is critical to being able to do that. And then finally in this topic, we go through the difference flow tool, which isn't strictly related to aggregations. It's just kind of tacked on to this topic, but it allows you to see how things change between two different cases, or you can even have one case where you make a change in the case, like you disconnect a load or you disconnect a generator, and then you compare the before and after. So it's useful for that. And you can also take like different generations of the same case. Like I'll show you an example where I take a Western case from 2016 and compare it to a Western case from 2018. and then you can see like which loads and generators are new, which ones were taken out, and things like that. All right, so for areas and zones, these are part of the standard text file format. So what we mean by that is the EPC files in the West and the raw files in a lot of other parts of the industry. Every bus in the case has to be assigned to exactly one area. It can't belong to two, and it can't belong to nothing. And then the same thing for zones. So you can also have a situation where a generator or a load or a switch shunt might be like a capacitor or an inductor. Those are normally assigned to the same area as the terminal bus, but they could also belong to other areas. And we've seen this particularly with loads where there's a distribution circuit behind the load that maybe belongs to a different utility or something like that than the substation that it's connected to. So you can sometimes see that. And then the load looks like an export from the area of the terminal bus to the area of the load. So that's all accounted for in the transaction. So that's how that works. And just another thing, it kind of depends. Different regions have different conventions for how they do these. Like sometimes zones serve as a sub area. So maybe you have like different utilities in area northwest that are all kind of belong. The buses and the generators and the load that belong to these different zones all belong to the same area, but it doesn't have to be that way. You can have a situation like this where you have two different areas and two different zones, and they kind of mix and match. So I think you see some of that in California, where they have their loads are kind of classified as different types, like industrial load and conforming load and non-conforming load, whereas like the conforming load kind of follows the general shape of the daily pattern, and the non-conforming load maybe is an industrial load or something that might be running at night also. And then the zones that those belong to might be in multiple areas. But anyway, the key point is the software lets you do whatever you want with it. It doesn't have to be a subset of an area you don't want it to be. So both areas and zones in Power World Simulator provide summary data about groups. So you can look at the total load in an area or the total load in a zone. Same thing with generation losses, things like that. We have area zone filters that you can use to just show things on the display that belong to areas of interest or zones of interest. And then you can also, in your limit monitoring settings, turn on or off settings for everything in an area or zone. So just kind of like these accounting things are really the same. Areas have control settings where, for example, you set the export level of megawatts for the area. You don't really have that for a zone. You can look at the zone exports, but they might float just depending on other changes that you make. Whereas with the area, as long as you have AGC set to something other than off, then there's going to be some fixed, or it could even be a range, but it's going to be the megawatt transfer from one area to the next is going to be controlled software, unless you turn the AGC off. So, and then we also have situations like with, for example, generator AVR or transformer control that you can like turn entire classes of controls on and off at the area level. Generally, these all apply to super areas as well. So if a super area is on control, then it overrides the settings for the individual areas that belong to it. We'll see how that looks later with an example. Most of the time, of course, if you're working with existing cases, you don't need to create new areas or zones. You're just kind of taking what you're given. But if you're doing something like a generator interconnection study, maybe you're like modeling a new farm or something like that, maybe you want to put it in its own area, or you want to change the assignment perhaps for some reason. So you can do that in the Model Explorer. You can also do it from the dialog. You can do it from an auxiliary file. So just to kind of show you what I mean by that, I'll switch over to PowerWorld Simulator. And I've got just a test case open here. This is our B7 flat. I'll do some examples in this, and I'll also do some examples in a WEC case as well. If you're following along, a lot of these examples in here are kind of generic, so you could still do the same steps in any case. It's kind of universal. But where this case comes from is if we go to File, Open Case, and if you've got a Training Cases folder or you've got a folder called Sample Cases, then you can navigate to that folder and you can find B7 flat case as you prefer. So we can see here, if we go to the case information and the Model Explorer, try to increase the size of the text in here so it's easier to see with the screen sharing going on. But if we look at individual buses in the case, it'll show the area number and the zone number. And you can just change those. Like if this generator down here was one that you maybe wanted to model in a different area, if you just type in a different number for the area, if that area, I just typed in area 4, if area 4 isn't really already an area in the case, it'll just create it on the fly. And you can do the same thing with zones. Like you do some things to like zone 2, whatever. And that's one way to create an area, is you can just assign objects to it. And then if I go over to my list of areas, I now have a new area called 4. And it defaults to off AGC when it's created. So we might want to change that to something else, depending on what we're trying to do. And if I go under aggregations to zones, I've got a second zone in here as well. Whereas before, I didn't show you what it looked like before, but before there was just zone 1. So we can see like it does the accounting of the load generation that's in the zone, but there's no AGC function for the zone. So it's not going to try to hold exports at a specified value. It's just going to show you what the exports are. In this case, it's the interchange megawatt. So that's like how much is flowing across the tie line from 1 to 2. Because we only have 2, the numbers are the same, but with the opposite sign. It shows that for megabars as well. And as I mentioned earlier, we moved the buses and the generators. If I go to my generator display under network, by default, we don't show what area or zone the generator belongs to, but you could add that to the case info display if you wanted to. Just that's shown in a different training topic, how you customize this. But just kind of in summary for that, what we could do is we could go under the display column options here. So I'm just mousing over this icon up here to show the display / column options. And if I open that, then I could look at the folder called area over here on the right and expand that by clicking on it. And I can see there's a area number of the bus, also one for the generator. And then it has the names also. None of these fields are presently on the display. But if I wanted to add them all, I could just select the field that I wanted to, or if I wanted all of them, I could just select the whole folder and then click and drag that. So I'm just left clicking, dragging over here to the right. I'll just put it at the end. But you can place it anywhere you like. And now if I scroll over to the right, I'll see those fields. And what I did in the other display was I changed the area number that the bus belonged to, and it automatically moved the generator to the same area. But I could have a situation where the generator is in a different area. So if I typed in area 5, it kind of gives you a warning because it's this non-standard, I guess. We could just say, yes, we want to do that. And now the bus in this display, the area number that the terminal bus belongs to is read-only. So it's black. If I try to type in there, it doesn't let me do anything. I would have to go to the bus, back to the bus display in order to do that. So that's how you would change that. Or if you just wanted to browse it and see if you have situations where, for example, I think it's more common with loads. Because of the distribution network that's not shown in the power flow transmission model. You can have situations where maybe some loads belong to different areas, and then you would see that. And you could do things like create an advanced filter, which we talk about in other training topics as well, to see, which generators or which loads have an area number that's of the bus that's different the area number of the generator or load. And you can do the same thing with zones. If I go back to the display column option, there's also a folder in there for the zones, and you could move those fields out there. Well, you can also create areas or zones, kind of the more traditional way in Simulator, where you go to that object's grid and you right-click in it, and then you insert area. So I could put in an area 6 now. And it's grayed out because it's empty. There's no buses, there's no loads or generators in it. And if I just mouse over that, it tells me why it's grayed out. It's because the area is empty. So, and you can do the same thing with zones. If I right-click in here and do an insert, I could add a zone 3, and it's empty until I put stuff in it. But kind of the different ways to create them. And like I said, normally, if you're working with a wet case, you're normally just kind of a user of the area in zone data. But there could be situations where if you're wanting to study something that doesn't exist yet, maybe you want to put it into its own area or its own zone, or maybe not. It just kind of depends on the nature of the study. Sometimes if I'm modeling an interconnected generator that doesn't exist yet, I like to drop it into its own area, and that way I can play around with the exports. I can export the power to area A or area B or whatever and see how that changes. And it's really straightforward to do if the new object, the new generator, is the only thing that exists in the area, because then if you set the exports to 500 megawatts, then that new generator would then produce 500 megawatts to send to the actual generator. We talk more about auxiliary files and copying and pasting from Excel, but you can also use those techniques, of course, to change an area or zone, provided you're on the right object. You're on one where the text is blue, which means you can change it. Then you can read it in to alter the data as well.
No, that makes sense.
Okay, great. Okay, next we'll move on to interfaces. So I'll go to File, Open Case. And if you wanted to do a similar example, you could just grab an EPC file that you have or any other file that you have. It could be one that's already in the PowerWorld binary format. But I'm going to change to do the EPC file open, of course. In this dialog, you change the file type. See, and I've got, this is an older one from 2016. I'll just open that. I don't need to save what's in here right now. Okay. So yeah, it's dropped me into the Model Explorer, and I will go down underneath Aggregations, and I'll look at interfaces. Yes, this case does have some that are in there, so this should kind of look familiar to you.
Yeah.
But you can, so in this display here, you click on a particular interface, and then it shows you what elements belong to it. And I think for the most part, the industry uses these to group lines together. But you can also add generators, and you can add loads and other things. It looks like we even have like a generator open object, and I think that's like for coming up with the impact of a contingency, like the loss of a generator. What would that do to the flow? So we have that for branches too, which is a little bit more common. You can have like an interface that looks at the flow on one line if another line is taken out of service. If you just choose, so each of these tabs will give you a filtered list of the elements that are of that type. So, and then the fields that are shown might be specific to that element type. So branches show losses in them, for example. Generators will show, if this would only show the generators that are part of that interface, and there are none, so it's fine. But it would give you about that. So if we wanted to create an interface from scratch, we would just right-click and insert. So I can do that, and then I can give it a name. So call it like at 25 or something. I'm not sure in real life what that is, but you just give it a name. The number should be unique, but I don't think it's a key field that's enforced. So you could, it would be bad practice if you could pick a number that already is being used for something else, but I would suggest not doing that, because then if you've got auxiliary files or other things that use the number as a key field, it can be ambiguous. The name, I believe, is forced to be unique. So you could not create a new interface that has the exact name of one that's already in there. But yeah, then normally this is the monitoring direction for the whole interface. So this is like, which end do you look at for the flow? The flows that are looked at in an interface are always megawatts. So whereas lines, the limits could be MVA or they could be amps, but with interfaces, they're always megawatts. So yeah, we'll just leave that as from to to. And then down here, we'll define what belongs in the interface. And you can right-click in here to insert. There's also a button for inserting a new element. But I'll just insert from here. And then you can just pick different object types. So lines are the most common, but you can have also these different object types too. Some of them are kind of dynamic in terms of how they're defined. So if you picked area to area interface element, for example, it would grab all of the tie lines that belong to that area that go to the other area. So from the near area to the far area. So for example, I could pick one that goes from area northwest to area BC hydro. And that definition is going to go and look at what those tie lines actually are. If you go into your case and you create a new tie line or you remove one that was there before, then the definition will change with it. It's just, it's grabbing everything. It's like a pointer that grabs everything that fits that description. So that's one item. So I'll go ahead and insert that, and then it'll calculate the flow. So what this tells me is this, in this case right now, there's actually 2,300 megawatts that's going from BC Hydro to Northwest, which is why that's negative. So I could also insert them going the other way, or I could also do something where I monitor in both directions. That can get a little bit messy though too, because then you would have to put in positive and negative limits. Well, but maybe the positive limit is 2,500 and the negative limit is 400. They can have different absolute values in each direction. And you can put in A limits, B limits, etc. down to, we go all the way down to O now, so that's 15 different limits. But when you're done setting the parameters, you can click OK, and then it'll add that interface to the list. I tried to scroll down to the bottom to see it. Where did it go? I'll just sort. I'm not sure where it dropped it numerically. I'm sorting in ascending order on name right now, and I can see there's the one I just created. And then if you give it limits, it'll tell you the percent of flow and so forth. And then you can edit existing ones too, just by right-clicking on the interface that already exists and choose Show Dialog. And then you could add or delete stuff. Like if you wanted to remove an element from that, you could do that. We wanted to add something different. We could add a generator to it. Whatever makes sense, I guess, for you. The generator object will just be the megawatt output of that generator. So this probably doesn't make sense, but I can add this. Now that'll get added into the total flow. And you can change the weighting level for individual elements too. So if you want this to be weighted double, you could put in a 2 for that. And it tells you what the pre-weighted flow is and then what the product of the pre-weighted flow and the weighting is. So, and the total sum incorporates that. And like I mentioned, I won't go into all the details here, but if you wanted to have a line open contingency, you pick a line, gets taken out of service, and let's see, these are in Idaho, so I'll probably, just to make sense, I'll pick something that's nearby. So I'm sorting I've got line open contingency here on the left, and I'm sorting by number. So I'll just scroll down into the 60,000s here. Pick something, 230 kV line maybe. And so this is kind of a topic unto itself, but and we discussed this a little bit more in our optimal power flow training topic as well, because you can use these as kind of a proxy for contingency modeling in the optimal power flow. What we're doing is we're modeling the flow on kind of the base interface elements during the outage of this line. And right now it shows nothing because you have to solve the power flow, and you have to solve the power flow with the setting that will compute these. We by default, don't compute them because it can take additional processing time. But if you want to include those in your interfaces, first I'll finish making this interface by clicking OK. And then I'll go to simulator options. So you can grab this from a few different places, but I'm on the case information ribbon up here right now. So that works. I got simulator options right here. I click on that. And then I go to the general tab. And, oh, actually this is set. So it's set to calculate the contingent interface elements during the power flow and the optimal power flow, but not during contingency analysis and FCOPF. So this is kind of a broader topic that we get into more when we look at the optimal power flow. But if I just choose that option right there, then the next time I solve power flow case, and I hope this case solves without any issues, I didn't check that first, but I'll go to my message log and then just open that, and then I'm solving the power flow with this calculator icon up here in the quick access toolbar. It does solve, so that's good. And it tells me in the message log that it updated the contingent interface flows. And then I can see in my results for the interface that I just edited, that I put the contingency line open element in, it's got a contribution. So the contribution to the flow on these other elements, looks like I picked one that was sort of nearby, but not really. It's only 1.5 megawatts, but it decreases the flow on the interface by 1.5 megawatts when you open that line. So that's what that calculation is telling you. And then it's reflected in the total and so forth. So, and again, these different views down here just show you the elements that are of that type. So because of the changes I made here, I added a generator and I added a contingency open element. If I go to the branches, I only see the 7 elements that are branches. If I go to branch open, I see that one element that I added. If I go to generators, I see that one element that I added. Okay, great. I did one example of an area-to-area interface where I picked area northwest to area BC hydro, and I manually inserted just one interface that met that particular criteria. You can also auto-insert interfaces that are area-to-area or zone-to-zone groupings. So if I go back to my case and I go and I right-click up here in the list of interfaces up here, I go to interface records, auto insert interfaces. Then, yeah, I just have the choice of area to area or zone to zone. And it's got to give them all a unique name. So you can optionally put in like a character string. Maybe if you wanted them to like all sort kind of in the same place, you could maybe put like A to A or something like that. If you wanted to get rid of all the interfaces that are already in there, you could check that box. And if you only wanted to insert the ones that meet the area zone filters, again, we talk more about that topic in a different training topic, but you can do that. And then if you wanted to assign limits, normally you wouldn't assign the same limit to every area-to-area interface, so you could leave these 0. If you choose to automatically calculate from the component ratings, it's going to sum up the limits on every tie line and then assign that. But normally, you would want to put in an interface like this if it had some different limit, particularly a more restrictive limit to some of the tie lines. So it really just depends on how you want to initialize that. I would usually just leave these defaults, and then you could go to the individual objects that get created and set limits that are appropriate for that one. But when you're ready to insert them, you just click insert here. And you can do the same thing for zones. I won't go through the example of the zones, but oh yeah, and I'm already sorted right here by name. So when I click on that, so I can see it auto inserted all these others, and it put the character string A to A to it. So I could go in and put the megawatt limits associated with that. There's also some other things you can do with interfaces if you right click on them. So like one example that sometimes might be useful is you right click on it, you go to interface records, and then you create a reverse direction interface from the selected one. When you do that, it automatically gives it a name that's identical with the word reverse in parentheses appended. Of course, you could just change that, but then you can see that it has a negative value, but it's just monitoring everything in the opposite order. And we could go to, oh, this is a multi-section line flow. So in this example, it just monitors that in the opposite instead of the original one was Coronado, the Silver King, and then this one's the opposite. And then this dialog right here just shows a similar example on the small 7-bus test case where we have just 3 different areas, and it's got the area-to-area interfaces, and then you end up with 3 resulting objects. And I believe what this does is it automatically assumes that the area with the lower area number is the from side. The other one is the to side. But if you wanted to monitor it in a different direction, you could just use some of those other techniques that we did. You could manually insert it in the opposite direction, or you could right-click on it and say, insert the opposite direction interface. Or you could use this option to monitor the interface in both directions. But just know that if you do that, then you have to put limits in the positive and the negative direction in order for the limits to really be used. Otherwise, it's going to be, the limit will be 0 in the other direction. Okay, so that was the area-to-area and the zone-to-zone interfaces. And then we also kind of covered this. If you want to just make an interface from scratch, you can right-click in there, insert the new one, and then pick the elements that you want to add to it. This example operates on the 7-bus case, so 2 to 6 and 5 to 7 are the elements here. And then, yeah, especially if you auto-insert them, you might want to go back and just change their name. That's easy enough to do. But you can just type something different in here. And then, yeah, we also talked about the different element types and then did an example, various examples that had lines and transformers, line open contingencies, area to area, and then just know you can also do DC lines and injection groups. And, you can even nest interfaces inside other interfaces. But yeah, there's a warning, don't create a circular reference. So if you have an interface that's made up of a few different lines and then you put it inside another interface that has the same lines, then I think that kind of wouldn't make sense. So, or you could also take an interface and make it belong to, you can make interface B belong to interface A, then also have interface B that has interface A in it. That wouldn't make sense either. But yeah, that's some options. And then some additional ones that aren't shown on this slide are like the generator open and the load open objects, which operate very similarly to the line open and close. Yeah, and this is just a view of the dialogue that we kind of looked at, and in there you can edit things like the weightings of the individual elements. And of course, you can also do that from the Model Explorer. Yeah, and we talked a little bit about the weightings. So by default, they're going to come up to be 1, but you can make them something different if you need. So as we mentioned earlier, nomograms allow you to have a limit space that looks like this. The picture is kind of the easiest way to describe what it's doing. But as I mentioned earlier, you can have 2 different interfaces, like this one's interface A and this one's interface B. And what's shown here is that each one of them has a limit by themselves of 100 megawatts. Those are just the numbers that are on the graph. And if you didn't have a nomogram, then the limit space would just look like a rectangle. Like this one could be anywhere below 100, and then this one would be anywhere below 100. But you can also create a limit space that takes away part of that rectangle, if that's appropriate. Really what you're doing is you're setting these breakpoints in here. Yeah, you just enter those, and you can have as many different lines and breakpoints as you want. So I'll go under aggregations to here it is, nomograms. It's grayed out. We don't have any yet. And you can create them kind of from scratch, or you can clone interfaces that already exist and then bring them in. But if you clone interfaces that already exist, it'll just like make a copy of that interface. The original interface record will still remain unchanged, but what you do to it in here will affect just the nomogram itself. So I'm going to just right-click in here and choose to insert one. And this is interface A up at the top, and this is interface B. So I'm just going to build these by cloning, but you could do it either way. I can show you. If you want to build the interface A and interface B from scratch, it's really, the tools are kind of the same as they are when you're building an interface itself. You just have to do it twice. You do it here, and you do it here. But I can right-click and I can insert an element like that, and then this dialog is the same as what it looked like before. Or I can click the button, insert new element. I'm just going to shortcut and grab elements that already exist in the interface. I'm just going to grab a couple of them. But I'll just click clone elements from, I'll take maybe west of Cascades north. That's a whole bunch of them. And then down here I'll clone west of Cascades south. Yeah, what we're doing here is we're just inserting the breakpoints. So I can say, like interface A, and what we want to do is we want to include generally these 0 points here so that it'll connect all the way out. So we could put a breakpoint in of like 0 for A, and maybe, I don't know what's appropriate for these, 2000 for B. Okay, this kind of makes more sense. So what I'm doing right now is I'm putting them in kind of in order, like moving clockwise around the curve like this. So yeah, and then you can have a point that's down here, like maybe 1500. So yeah, now we're starting to build that shape. So it's like flat to here. it gives you some freedom on what to do, but it has to be a convex shape, which means like it can't. You couldn't have a point like in here, and then connect from here to here to here. So you'd have to be able. The shape would have to be where you could take an arbitrary two-dimensional line in this Cartesian space, and then like move it towards the shape, and it would intersect at exactly one point or at a line. You wouldn't have it like go through a point and through some empty space and then through a different point. That's not allowed. Then I can put in, so I'll just come back out and do shape that's back in the other way. Anyway, so yeah, now I've built a convex shape and it's happy. And the order that you put the points in does matter. So like just move clockwise or counterclockwise around that space. But once you've built it up, then you would give it a name. I think we can just click save. And it'll prompt us for a name. So call it west of Cascades. Nomogram. Click OK. Oh yeah, graphically it's showing, so I picked limits that weren't really appropriate. It's showing me that the operating point is like way out here. So it is violating, but that's okay. Yeah, because my actual flows are much higher than 2000. So yeah, we've got a violation here, but go in and edit those numbers if appropriate, or just put in appropriate numbers in the first place, and then that would work. So this will just show up as limit violations. Yeah, they can be used in these other tools. So like if you do ATC analysis or contingency analysis, they can also be binding constraints in the optimal power flow or the security constrained optimal power flow. So yeah, here's the dialog that we look at. And again, yeah, the points are put in a specific order where you're moving either clockwise or counterclockwise around that space. And this is an example where the operating point is boundary, so it's not a limit violation. And yeah, you can look at them in the Model Explorer also. So this is the whole nomogram, and then so segment 1, 2, 3, and 4 represents these 4 lines that define 1, 2, 3, and 4. And you can have more than 4 too if you've got more breakpoints. I just put one in that kind of mirrored what's going on here. This next section of slides just talks about what you can do on the one-line diagram. And some of our customers use one-line diagrams, others don't. And some do different things with them too. I like to use one-line diagrams. I don't usually put, especially interfaces, I don't usually put them up there. But maybe there's a situation where you want to like just display the flow on an interface kind of in a with some flow arrows and things like that, even if it doesn't really make sense on how to lay it out geographically on a one-line diagram. You can still put an object on there that'll show you the flow, and you can have arrows and fields that are associated with it as well. So do that with all of those. Areas, like typically you could use areas to look like a bubble or a box, and then have the interfaces kind of go in between them. So I'll do an example on this case where, yeah, we just make a one-line diagram with areas and area-to-area tie-line interfaces shown on there. So we'll go to File, New One Line. And I like, especially for areas, because there's never, there's usually tens of areas and not hundreds and thousands of areas. So I find the palette to be really manageable way to work with these. But you can also other tools on the draw menu. So when we go to create a new one line, it automatically bounces us into edit mode, assuming that you want to put something on that one line. You have to be in edit mode to do that. So I'm in edit mode. You can grab these objects that we talk about in this section are all under aggregation. So you could grab an area, an injection group, an interface, like click on that and then click in the background of the one line to drop it on there. Like I said, I kind of like to use the palette, especially for things like areas and zones, because it's really easy to look at all of them there. So I'm going to palette for areas. And then over on the right here, I see all the areas in the case. So I can just drag and drop those out there, like drag and drop Alberta. I know it makes it big. So yeah, the scale on the new one line is such that object I just dropped out here is huge. But what I'll do is I'll just hold down the control key and then page down. I'm zooming out so that it looks nice. And you have to, before you do that, you have to click in the one line, like make sure that the palette is not the active window, but that the one line is the active window. And then you can click and drag and kind of move Alberta around. But once I have Alberta on there, I can click on it and it'll show me the neighbors to Alberta that are not on the diagram yet. And I can click and drag those out. So I can put BC Hydro over here, Montana down here. If I click on BC Hydro, you can see Northwest, Fortis, so forth. You can put as many, you can put all of them on if you want, or just the ones that you want. Maybe we'll put Northwest neighbors on. LA is a neighbor because of the multi-terminal DC line, I think. Got some AC connection. Put Idaho out to the east and Nevada kind of down here. And then you can change the background color. We go into the topic of like how to format one line objects in the first section that deals with one lines. But if you click on something, you can open the format dialog and change parameters like that. You can also change the default draw values to make all of them follow a certain convention. That's on the one line ribbon here, default drawing values. You can look at the defaults for areas and change that if you want. And then you can also auto-insert the interfaces. So I can go back to the draw ribbon and hit this drop down for auto-insert, pick interfaces. I'm just going to keep all these defaults here. And then it just draws those. So yeah, I've got like some spaghetti that I kind of need to clean up, so I can click and drag stuff around. But that's kind of neat. And then like I said, if you want to just show, if you've got a diagram, it can be any kind of diagram. It doesn't have to be bubble areas with interfaces. It could be something with buses or substations, but if there's some interfaces that you're interested in, but they don't have like a well-defined, like a single from and to end, like it's an interface that contains just random lines, then you wouldn't display that with terminals, because the terminals are many different buses. But you could still go to aggregation here and add an interface. And when you get the little crosshairs, this is kind of the same as like drawing a line. So you don't want to click and drag because that'll just make a mess. But you can single click where you want to put it. And then again, don't click and drag, just single click. If you want to put a vertice somewhere, you can single click again where you want the vertices. And then where you want to terminate it, you can double click. And then you can pick, you could create a new interface, just like you can create new buses and lines by using this. But if you wanted to pick one that already exists, we can just scroll down here. Yeah, I'll just pick Idaho Northwest. And then click OK. And then it just puts an object down there. And then kind of like with, we talk about in the other topic about how you can add fields to buses and transmission lines. The same thing applies to all the aggregations too. So I can add a field or an interface and then just click next to it. It kind of senses which one you're clicking close to, but if you really want a different one, then what comes up here, you can pick a different one. But maybe I'll put in the megawatt flow. And yeah, you can edit these parameters if you want. I'm just going to leave the defaults there. Click OK. And then that comes up kind of small, but if I want to go into format it, I can change the font and make it bigger. I don't know how big it has to be. It probably needs to be bigger than that too, just because of the scale of everything else that's on this diagram. But what I'm doing now is I'm zooming and panning with the arrows. If I hold down the control key, page up, then it'll zoom in, page down, zoom out. You can also hold down the control key and just use the up-down arrows. It kind of does the same thing, but in smaller steps. And then now I can see it. I can click and drag it and make it the right size. Whatever makes sense. But sometimes that's kind of handy if you've got like a list of interfaces that you want, that you always want to see what the flow is on them. And I'm still in edit mode too, so if I switch over to run mode, now I don't see arrows. But it's probably because of the scaling, but we could show our animated flow arrows. This is the same for interfaces or for anything else. We do talk about this more in a different topic, where you can go to your one-line options. So I'm on one line options. And then I can go to animated flows. And I'm just going to use the shortcut button to set the size and the density and the reference for what's on there. And that'll change these numbers down here. And then I'll click OK. And then there's other examples. We're going to talk a little bit next about substations. I'm not going to go through the mechanics of adding those on there. It's kind of the same way. If you go to the draw ribbon and switch to edit mode, you can add zones, you can add super areas, and you can add substations. It's all kind of the same. Slides here. Yeah, so we added interface fields. You can also add area fields, like if you want the total megawatts generated in the area, for example. And it's the same field. You just go to field. Instead of interface field, you do area field. You click next to the area, and then you pick what field you want to see and change the size. And yeah, we inserted an interface field, so we saw a similar dialog, but it had fewer options. For areas, we've got, I guess, more commonly used fields, so there's more buttons down here. But in either case, whether it's an interface or an area or zone or a super area or whatever type of field you're trying to add. We show the more common ones with these radio buttons here that you can pick, but if you want to actually put a field on there, it's not shown in the short list. You can just click Find Field and then go out and grab one that you want. Okay, so here's the area field example. Again, we did an interface field. I'll just kind of gloss over this, but this is an example on the 7-bus case. This is a background rectangle and then like 4 different area fields. So how much flow is going from area top to area left, how much total generation is in area top, how much load is in area top, and what the AGC stacks of it. And I believe the word top right here is just background text. Or it could be the area name, I guess. Either one would show the same results. And then this stuff right here is like, these are just text fields. So you could add that on too. Like, if I wanted an explanation of what is this, I could right click on it and then go to the field dialog. One thing I could do is I could give it a prefix, which is like whatever I want. I could say, say megawatt flow with a colon on it. And then you could also just put in background text that's like right next to it that says the same. So just whatever you prefer. Okay. So yeah, this slide just describes that you can kind of do the same thing for areas and zones, super areas. An object to represent it, and then also put in interfaces. This is just a screenshot from doing it on the 7-bus case. Yeah, and I like I mentioned, just kind of a personal preference. I like to use the palette, especially for things that have a small list. You can also use the bus palette too. Initially, if you've got no buses on the display and you're trying to add a new one, you might get a really long list over here. But then once you add one, then you can click on one that's already on there, and then it will show you the neighbors, which would be a smaller list normally than every. And we did some interface fields like the flow on that one. And you can also auto insert if they're tie line interfaces between areas or zones, you can auto insert them, and that's exactly the step that we took to get these on here. And to draw, auto insert. And yeah, this is just an example with the 3 areas and then some interface fields added to show the flow on the interface, and then some other fields that pertain to area top. Okay, so next we'll talk about super areas. And as I mentioned earlier, these can be kind of handy for like grouping areas into a larger area without getting rid of the underlying area. So for ISOs or RTOs, it can be useful. And there's a couple different ways to create those. One, you could just go to the area record and give the area, kind of like we did with the buses. We created a new area by assigning a bus to an area that didn't exist. You can kind of do the same thing to make a super area. You would go to the area field. So zones don't belong to super areas, and buses and generators don't belong to super areas. It's only areas that belong to super areas. So we can go to the area list in our case info display. And if you don't already have it open, you would go under aggregations, find areas. Let's text a little bit bigger, and then we can go to our display column options again, and then find, here's the field right up here, super area to which area belongs. And we can just drag that out there. Maybe I'll put it right after the area name. And it's blank because the super areas don't exist when you open an EPC file. In fact, if you make them and you save back out to the EPC, then the super area data would get lost because it's not supported in that format. But if you save it to a PWB, of course, it would cover that. But what I could do something like go to maybe San Diego, call area FISO, super area FISO. It tells me that it doesn't exist yet, but I'll add it. I could add maybe Edison and to it. But yeah, LA is actually separate. It's for an IID separate, I believe. Anyway, that's one way to create a super area. Now if I go under my aggregations grouping and open super areas, it hasn't refreshed this. It's still showing that it's grayed out. But if I click on it, it'll know that there is one. And then when you create one, by default, it's off AGC, which means that the individual areas will still be doing AGC, but you can also change this AGC status to participation or economic dispatch or optimal power flow if you wanted to do that. So I could put it on participation factor control, for example. If I do that, then if I come back to my areas, the AGC status for those will all be grayed out. And just what that means is it's not being used. You can mouse over, of course, anything that's grayed out. It'll tell you why it's grayed out. So it just says that the area is part of the super area that's on control. So, and then what super areas are going to do is they will sum all the export. You don't really set the export value at the super area, but rather it just sums everything up from the member areas. So if there's any transactions in the case that go from a member area to a non-member area, those will be summed up as like the total export obligation of the super area. If there are transactions that go in between member areas, like from San Diego to Southern California, I don't know if they exist, I could right-click on, say, San Diego and say show dialog for it. And I can see there are some transactions. It's importing from Arizona. It's exporting from Mexico, from Imperial. It actually really doesn't have anything that goes to another area. But if it did have an export that went to another area that was in the same super area, it would just be ignored effectively. So if I look at the super area records, it shows the generation, the load, and the total scheduled megawatts, so it's importing 10,500 megawatts. That's the sum of all the scheduled imports for the individual areas from other areas that are not also part of FISO. If I don't do anything right now, if I just solve the case, then it shouldn't move anything because I'm satisfying the individual areas. Were satisfying their export obligations, so the sum is kind of still doing the same. But if I added a new transaction, for example, let's say I went back, and again, you don't add the transactions on the super area level. You do them at the individual area. But let's go back. Let's go into San Diego, for example, and right-click and show its dialog again. And on this list of exports on the Info Interchange tab, let's add one that goes to Northwest. Let's put in like maybe just 200 megawatts. And then I'll enter that. So then I'll click OK and close that. Upon doing that, I've now created a 200 megawatt error that's negative in San Diego and positive in Northwest. And then when I solve the case, it should clear that out. But because the San Diego is part of the super area, it's going to use a participation factor control, meaning all the generators in the whole super area. It probably won't resolve this so that San Diego goes to 0. Northwest should go to 0. But these others might all be non-zero, but they would hopefully some go about 0. So what I mean by that is I'll turn my message log on up here and solve the power flow case to make sure we're good. And now my area northwest ACE is now 1.33, which is within the tolerance, so that's good. But these others are kind of like all over the place, but they basically sum to 0. So again, it's not enforcing the individual exports of each member, but rather it's using the super area to act as one area, even though the other areas still exist. They're just not on control. So if I go to my super area record, I see that that ACE is close to 0, which is good. And it's meeting the export obligations. So again, it's just treating every generator and load that belongs to one of its members as belonging to the whole thing. So again, it's useful for ISO or RTO modeling where you want to have imports and exports for that greater region, but you don't have to destroy the individual records. If you wanted to go back to the way it was before, you could just turn the super area off control. Although, I mean, be careful doing that, because if you've made a bunch of like gradual, small, incremental changes, and it's got everything kind of out of whack, then maybe you go back to this, maybe it doesn't solve because it's trying to move too much power at once. But in our case, I just did 200 megawatts. I should be able to undo that by solving the power flow. And yeah, in fact, it does. I don't know if it goes back exactly the way it was before because I'm using areas. I guess it probably should because I'm using area select with these three. So the whole ACE should go to the same spot. Anyway, and you can also create. So yeah, I use the method of just creating one on the fly from the area records. You can also come over here to super areas and right click and choose insert. And then you can add individual areas to the super area down here. And we've got a couple different ways of doing it. Like you can put in a range of numbers, or you can just right click in here and insert. So maybe I want to combine northwest, and I can hold down the control key and make a multiple selection, or the shift key, and it'll pick a whole range. But maybe I just want to put Northwest and Idaho and Pace or something like that. One. Then I'll click OK, and it makes the super area. Initially, it's not on control, so I could just leave it off control, and I can give it a name. West RTO or something. I could leave it off control and then just kind of use it as accounting and sum everything up. You can't, an area can only, of course, belong to at most one super area. It wouldn't make sense for an area to simultaneously belong to two. If you assigned an area to a different super area, it would take it out of the first one. It could belong to no super area, but it can't belong to more than one. Yeah, and then there's different, we didn't look at these, but there's summary information, OPF, and custom is like where you get the strings and the floating points and stuff like that. And yeah, this is just showing the 7-bus case where we've got the whole thing on economic dispatch control. So if you just kind of visually inspect the one-line diagram, you can see that we're actually exporting power from area left because it just has one generator, one load, and they're not matched. So it's exporting 48 megawatts somewhere. This guy's importing 200 megawatts, so the rest is coming out of here. But because the super area is on control, it's allowing those transactions to float to where it kind of makes, in this case, because it's economic dispatch, it's picking the lowest cost dispatch across the whole case instead of trying to dispatch the three areas separately and holding the exports for each of the three at some fixed value. Like ATC, for example, you can do area-to-area transfers, but it's really convenient to use injection groups because then you can bundle everything together exactly the way you want it. And when it's done running the analysis, of course, it'll go back to the starting point for you automatically. It does that with other objects too, but it just allows you to be very specific about what you want to use as a source and a sink with these different tools instead of relying on the definitions that are already in the case, which may or may not make sense for the transfer that you're trying to do. So creating an injection group is very, very similar to creating an interface in that you go to the list of them, and there aren't any in this case, but if we wanted to create one, again, it's kind of the same steps. We could right click in the background for the injection group and then choose insert, and then we give it a name. So maybe we could create one called Northwest or Hydro. It could maybe something more specific to, like, Upper Columbia River, or whatever makes sense for what you're trying to do. But just give it a name and then click OK. And then we bounce into here, and then we add. We can add generators or loads. I think you can also add shunts. You can add other injection groups, but most commonly you would want to add probably just generators or just loads, but it can be whatever combination makes sense for your analysis. So participation points, we'll insert points, and you can pick a bunch of generation. For these, sometimes the area zone filters are helpful, especially if you kind of just want to replicate all of the generation or the load that's in there. And we haven't really used those, but we can use those with interfaces too. I'll just kind of recap how those work and apply it here. But there's a button for editing the area zone filters. So we could click that. This just opens this dialog. And then maybe what we want to do is only pick area northwest. So we'll set the shown value for everything you know except northwest. And I find the easiest way to do that is just to go into that column and then use this set drop down to toggle everything to no. And then you just go back to the one that you want. If it's only one or two that you want to be yes, then you can double click on those, change it back to yes. And then I'll hit close. And now I also have to, I edited them, now I have to apply them. So I'll check the box there, and now it'll just show me the ones that are in the area northwest. So you can also apply a quick filter or an advanced filter. So you have to click define in order to use an advanced filter. But anyway, once we have them selected or found, we could just pick a few of them, like maybe we just want the Cooley generators, but it's easier to pick those. We're just looking at that list. So you could click select all to pick everything that's in the list, or you can click something and then use the shift button to pick everything in a range, or you can use the control button to just click on individual ones and make a multiple selection that way. But Then the next thing you have to do is initialize the participation factors. So these options, depending on whether you have a generator or a load or a shunt, you might see some different choices here. But if we wanted them to all be have the same value, then we could pick that. We could maybe set them all to 1. And what that would mean is that if it's participating in a transfer, every generator would incrementally move by the exact same amount, no matter how big the generator is or things like that. So you could do that. You could also grab the participation factor field that's stored with each individual generator and use that. I find it's like with generators, maybe it's handy to make it based on the megawatt capability. So larger generators would participate more. You can also, if you know the generators are going to be like sellers in the analysis that you want to do, maybe make it based on positive reserve so they all would increase and kind of hit their limit at the same time. Or negative reserve if they're going to be acting as sellers or sinks and they'll go down and hit their minimum limits at the same time. I'm just going to choose this megawatt capability and I'll add that. You can also optionally recalculate factors dynamically, and that matters if you might go in and then edit like what the maximum megawatt is or edit what the underlying participation factor is, then it'll just basically put a pointer in to the value. If you don't check it, then it'll create a participation factor for each point within the injection group, and that'll remain static until you go change it. And then we'll click Add. This puts all the generators on there. You can repeat this process too multiple times. Like if you wanted to then pick different generators, or if you wanted to go pick loads and mix them in there, you could pick loads and put them in the same injection group. Normally that wouldn't make sense, but there could be a situation where it would make sense. But the reason why you want to add them in a certain group is if you want to apply kind of the same standard for the participation factors to a set of them, and then you can go pick some other elements and use a different option. But once we're done, we click OK, and then it just creates the group that way. And then you can edit the values too, of course. Like I could go in and change these participation factors. I could change what it's based on. So I chose the generator capability, but you could do the max, you could do the increment, the decrement, so it's like the positive margin or negative margin. Or I could just make this a fixed value. A specified just means it's fixed at whatever number you put in there. And then the auto calc being like, actually yes doesn't make sense for that, but that's the recalculate factor dynamically in a field, so you can change that if you want to. And then if it's recalculated dynamically, then it's grayed out over here. I can't edit it over here, but the other ones I can't edit. Well, I have to put a number in, but I can put in whatever number I want. Step back. Okay, so then you have your injection group, and now if I go, for example, to a sensitivity analysis tool, that's on the tools ribbon. I go to sensitivities and PTDFs. Now I have the option of using an injection group, and I can pick my injection group. So it can be a participant there. It can be a participant in ATC or PV analysis and stuff like that. And then once you create one, of course, kind of like an interface, you can click on the big object, the container object, which is the injection group, and then see everything that's in it down here once you've created it. Okay, so yeah, this is the process that we used. We right-clicked in the background, and then we inserted one, and then we added points to it. this is an example in the 7-bus case where we're grabbing some generators. When we initialize the participation factor, that's just for creating, for setting the value at the time that we create the injection group. You can have it be based on, one of the options for generators was to make it be based on the generator object's participation factor, but then it becomes its own field once it's added to the injection group. Although some of them, if you use the dynamic factors, it'll go back and look at what's in there. So this just explains what that option is. And then you can also add injection group objects to the display. So it's kind of the same idea as what we did with areas. But you can have a rectangle that represents the group. This tells you how much generation and how much load is in it. So next up is substations. It used to be like the key reason why you'd want to use them is to kind of clean up a one-line diagram visually. But they're also very useful for other types of analysis. In the past several years, we've added geomagnetic induced current analysis, and those actually use parameters that are in the substation, like the grounding resistance and the geography of the substation is kind of critical in that analysis. So it's taken on a new significance from what it's always had, but kind of the idea is that you group buses together. So this just graphically shows a one-line diagram at the Cooley substation where stuff's just kind of a mishmash. Of course, you could clean this up too and make the lines all be orthogonal and not, as much as possible, not crisscross the topology, although there might be some amount of that you really can't get rid of. But if you just wanted to show what's happening at the whole aggregate level, you could create a substation and then put the substation, kind of like we do with the areas and zones and injection groups, you can put the substation on the one-line diagram. This is just the name of it. These icons here just show you that it contains some generation and it contains some load. There's some like local station load that's in there somewhere. So, but basically creating a substation, again, it's like the same as what we've done for the other like aggregate objects. We could go to a bus. I guess one distinction is that generators don't belong to substations. Like you can have a generator or a load that belongs in a different area or zone as its terminal bus. You don't really assign generators independently to a substation. They always belong to the substation that their terminal bus belongs to. But you can go to a bus and just like we did before, we could go to the display column options and we could add under substation, we could grab the name. Just grab like the name of the substation, drag that on there. For this case, they're all going to be blank. The EPC file now does support substations, I believe. So could be opening an EPC file, a newer one that has this populated. We go back to display column options. I go to substation and I pick for it will let me create from that. So I can just say yes to this, and it gives it a name of just sub 1. Then I think I can change this now at this point to Aberdeen. there's a refresh that didn't happen automatically. That's kind of an unconventional thing that I just did. But I created the substation by adding the new number, and then I just edited the name. But after I edited the name on the first one, I then clicked the refresh button just to update it, because for me, it's actually stored. Of course, now we have substation records. We can go under aggregations to substations, and I can see that I have one now. Yeah, the number is the primary key, and the name is the secondary key. So the number must be unique. The name is probably a good idea for that to be unique, but it doesn't have to be. There are more than one substation that's called Aggregation. But anyway, this just tells me kind of the summary fields for the substation. And then other useful parameters for the substation would be like the geography, perhaps. Then, like I mentioned, when we do geomagnetic induced current analysis, you could put in the grounding resistance for the substation, which would be an important parameter that would be used in that tool. And if I write, I can also show the dialog for that substation. Kind of like other objects, we can see like the summary data, which buses belong to it, which generator doesn't have any generation in it, does have one load, and so forth. I could add the geographic coordinates here, or I could also just add the latitude, longitude through the display column options to the display, and then go it that way. And you can also, create, same as we did before. Oh, maybe I have to be in edit mode. I think I do. So if I switch to edit mode, I can right-click and insert a new substation. Do it like number 2, give it a name, and then I can show its dialog, and I can add buses to it here. Kind of like on the zone dialog, you can move some buses from one substation to another. Yeah, a lot of times when we're working with these, we'll create the substations, and then we'll either use an auxiliary file or a spreadsheet to go to the bus records and then assign these values. So just assign each bus to the proper substation. And I've actually got a bigger example in this case right here. You won't have this case. Or maybe you do if you've built something similar, I guess, that has substations in it. This is a WEC case 20HS3 AP. You might have that case. We have an affiliate company called Energy Visuals that will build one-line diagrams for FERC 715 models. And here's actually this is a bus diagram. I thought this was going to be a substation diagram. But this shows all of just the buses. But the case, we've also gone through the case, added, I believe, most buses. Got some empty substations here too. And don't worry about trying to follow along here. I'm going to delete the empty ones so to clean this up a little bit. But now every substation in the case, or most of them at least, have a latitude and a longitude associated with them. Like I said, we're starting to see EPC files that have this information populated. I believe it's driven primarily by the GIC analysis. But it's kind of incomplete. Like some areas will have some data and some areas won't have any. This might be what it looks like if you had a case where they're all populated. This is kind of cool too. If you've got substations in your case already and they've got latitude and longitude associated with them, you could auto-insert them onto a one-line diagram. So I'll demo that here. If you have an EPC file that has some substations with latitude, longitude, you could follow the same steps, is what I'm doing here. But I could go File, New One Line, and then I could go to Draw, Auto Insert, Substation. And I'm going to choose the option here to auto insert using the longitude and latitude that's stored with the data record. So that's the stuff that you see in the Model Explorer. And if I pick that, I auto insert, what I'll have to do is go to the one lines and then zoom out to show the full thing. But here I can see all those substations kind of in Western geography. And if I want to add, we talk about in a different topic how you can auto-insert borders. So I'll go to the Draw ribbon, auto-insert borders, and then pick like all the states. And then you can auto-insert transmission lines and stuff like that. And you can also, just like we talked about with the other ones, you can auto-insert an individual substation, or not auto-insert, but rather manually insert individual substation on the diagram too. Pick from the ones that are there or created as you go. So the last thing I'll show is difference flows. And this isn't really related to aggregations. It's just kind of a topic that we tacked into this presentation. What you can do with this is you can take a case and make some changes to it and then look at the differences. And you can also compare like two different cases. So like I mentioned, you can have an older version and a newer version of a case. And I'll demonstrate it using kind of both uses of it. First, I'm going to go and open the B7 flat test case to do something simple, and then I'll compare two different WEC cases. The first one I'm going to open is B7 flat. You can, if you don't have it in your recent file list, you can go to Open Case, and again, go to that location where the sample cases are dropped. Go B7 flat. And what I would want to do is make sure I have a solved case, probably, although if you're just looking at topology changes, you wouldn't necessarily need to solve it. But I just hit the little calculator button, quick access toolbar here to solve the power flow. And what I'm going to do next is go to the Tools ribbon and go to the Difference Case drop-down and choose to set the present as the base case. And what this does is it stores the current system state and the topology in your RAM memory. And then you can make a change to it and then compare the difference. So like, for example, I'm going to click on this generator at bus 4, the little breaker symbol by it, and take it out of service, and then resolve the power flow. So yeah, now I've got different flows on my lines. And what I'm looking at right now is what's called the present case. And it says so down at the bottom that I'm viewing the present. But I could go to my difference flow drop down and then look at the base mode, which will take me back to that state that was there before. I can't really interact with this. Like if I try to click on a breaker symbol while I'm in base mode, it won't let me do anything. Kind of the same thing if I go to the Model Explorer, pretty much everything is read-only because it's the base case that's stored in memory. If I go to generators, I can't change any of this stuff. And we use like a different background color. It's kind of shaded light yellow here. And then also down here at the bottom, it says that I'm viewing the base. So it's read only. I can also switch to difference mode. And now what I'm seeing is the differences between the two cases. So this 45 megawatts of flow that shows up on this line from 3 to 4 means there's 45 more megawatts flowing with this generator out of service than there was before. And the generator itself has a negative 95 because in the base case it was doing 95. Now it's doing 0. We have this third mode. It's actually not in the slides, or fourth mode, called change mode. And what that does, actually the one-line diagram kind of looks the same. Well, the numbers are a little bit different, I guess. But if we go to the Model Explorer, it's only things that are basically the same from the base case to the present case just are not even shown. So, like for example, the status, the only thing that changed from the base to the present was that I opened generator 4, so you see nothing. So, yeah, it is showing present quantities and not difference quantities, but anything that doesn't change is hidden. Go back to present and we can see everything. Like I mentioned, you can also use that tool to look at differences in cases. So like what I'm going to do here is go to file, and you may or may not have a similar case handy, but this is a 2016 16HS3 EPC file. And I could open that. I'm just going to look at topology here, so I'm not going to worry about whether or not the case is solved. Just going to go up here to the difference case tool, set the present as the base. And then I'm going to go open a newer version of the case, which I have 18HS4. And I could go to the Model Explorer and, again, look at differences. And that might be something I want to do. Like I could maybe look at areas, and it shows that some of them have more generation or less generation. The name changed for Area 1 from one case to the other. That's kind of what this depicts. I think it used to be IID, and now it's Imperial, or maybe vice versa. Okay, the present case, it's IID. Base case, it was Imperial CA. But you can look at that. But then kind of a neat tool that works in conjunction with this is you can go under difference case to present topological differences from base. And then here it'll give me a summary of like how many buses exist only in my new case but not my old case. That's the new column. How many are removed, so how many existed in the old case but not the new case, and then how many exist in both. So you can kind of see that summary difference here. And then over here on the left, we've got individual folders for network objects and aggregation objects. I can see a list of which buses are new. Oh, and I'm looking at base mode right now. I want to look in present mode. You can also change it up here. So now I'm only looking at buses. These are buses that didn't exist in the old case. And I can do the same for loads. I can also look at stuff that was removed. So buses that existed in the old case, but it says the bus doesn't exist now. So these are removed. Then you can look at ones that are in bold. And then we also have a way where you can save stuff out to an auxiliary file. So, like for example, save to complete model. I could choose to save out only the new stuff, only the removed stuff, or only stuff that's in bold. So I could save out the new elements and then check OK. And let's call this WECC new. new. Now I have an auxiliary file that just has the new buses. This is just showing their name and nominal KV, new owners, new, so everything's new. You could subsequently use this tool, although it's kind of, if there's a lot of changes, it's kind of funky and it might not result in a solved case, but you can also save out the removed elements. And then in theory, if you ran both the new and the old, you could go from case A to case B. If you then loaded the auxiliary file into the old case, you would then create the new case. But the caveat with that is there might be a lot of changes and the case won't solve, but at least you have the topology that looks the same. That's something that you can do with that tool. And yeah, there's also a dialog. I just use the drop down up here, but you can also open this difference case dialog and then pick stuff. But I find it handy just to do most stuff from the dialog. But then the present topological differences, that's its own dialog and would interact with that. So here's an example. On the 7-bus case, I took the generator out of service, but you could like scale the load and then resolve it. Look at the current case, look at the difference flows. So what's the impact of scaling the load? Maybe some of the voltages drop a little bit in non-regulated buses. And again, this is just saying that it's read-only. If you're in difference or base mode, it's read-only. Change mode is like present mode, but yeah, I would be real cautious about it. Probably want to just be in present mode if you really want to edit the case. Just treat that as read-only also. So, and then this is what I did with the two different one cases. So you can open case 1, set it as a base, open case 2, and look at the differences, and then also look at the topological changes. This is an older version of the dialog, but it has some of the same characteristics. Now we have pages on the left instead of tabs across the top. But this is just looking at the summary information. This is looking at removed branches that don't exist anymore, either because the bus changed or the circuit ID changed.
If you need further assistance, please feel free to look us up on the web, give us a call, send email to our support line, or if you prefer to work with a particular Power World engineer, please feel free to contact that person directly.